This video was produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. Please see videos on hypothesis testing before continuing. This question was taken from the Higher Level Leaving Certificate paper for 2014. The question states that a generic drug used to treat a particular condition has a success rate of 51%. This 51% is our population proportion, otherwise known as P. So instead of saying 51%, we're going to write at 0.51. A company is developing two drugs, A and B, to treat the condition. They carried out clinical trials on two groups of 500 patients. The results show that drug A was more successful in the case of 296 patients. The company claimed that drug A is more successful in treating the condition than the generic drug. The question asks you to use a hypothesis test at the 5% level of significance to decide whether there is sufficient evidence to justify the company's claim. State the null hypothesis and state your conclusions clearly. In hypothesis testing, we state H0, the null hypothesis, and H1, the alternative hypothesis. The alternative hypothesis is given by the claim. In this case, the company claimed that drug A is more successful in treating the condition than the generic drug. Therefore, if this is our alternative hypothesis, our null hypothesis is that drug A is not more successful than the generic drug. I am going to tidy up the slide before continuing. For this question, we cannot use a z-score method. So what we do is base our hypothesis test on confidence intervals. For the population proportion, confidence interval is p hat minus 1 over the square root of n, the margin of error, and this is less than the population proportion, and this should be less than our p hat plus our margin of error. The first thing we're going to do is calculate our margin of error. So our margin of error is 1 over the square root of n. From the question, we can see we had 500 in our sample. So 1 over the square root of 500, which gives us 0.045. The next thing we need for our confidence interval is p hat. P hat is our sample proportion, or our population estimate. So in this case, our sample proportion had 296 who found drug A more successful, and there was 500 in our sample size. So this gives us a value of 0.592. So far, we have completed the first step of defining the null hypothesis and the alternative hypothesis, and the next step of calculating the values we need for our confidence intervals, i.e. the 95% margin of error and the sample proportion. We'll move on now to calculating the 95% confidence interval. To calculate the 95% confidence interval for the population, we fill into our formula. So p hat is 0.592, and then we subtract our margin of error, which is 0.045. This should be less than our population proportion, and this should be less than our sample proportion, p hat 0.592, plus our margin of error 0.045. When we calculate this, we get that 0.547 is less than p, is less than 0.637. Remember earlier we said our population proportion was 0.51. The next step in our hypothesis test is to find out if our confidence interval is true. Now I'm going to fill in our population proportion value into our confidence interval to see if it is true. So 0.5 0.547 should be less than our p-value, which is 0.51, which should be less than 0.637. This is not true because 0.547 is not less than 0.51. Following this, we state that our population proportion is outside the confidence interval. We must then state what this means. The result is significant, and since it is significant, we reject the null hypothesis. Following this, we must state our conclusion clearly. If we reject the null hypothesis, we conclude in favour of the alternative hypothesis. So we must state this. We must state that there is evidence to conclude that the new drug is more successful than the generic drug. That concludes this video.